If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
Okay, so in this video, we're going to go over some of the variations to these fundamentals in a slightly different aspect, in the sense of what are the variations to the interactions between the movable and structural sets. So the movable and structural sets can interact in various ways. How do they interact? And can there actually, the key question is, can there be multiple movable and structural sets? Okay, so with respect to the structural movable interaction, the placement of movable into structural elements or movable elements into the structural slots has several variations. It could be it could deal with insufficiency and excess. It could be balanced, imbalanced, or it could be determinate and indeterminate. So what do we mean by all that? Okay, so let's look at insufficiency and excess. Insufficient and excess. So we have this game here. It says 5 of 7 runners, A, B, C, D, E, F, and G, win places 1, 2, 3, 4, and 5 in a race. Not necessarily in that order. So we've got, once again, a sequence. We've got places 1 through 5 in a race. We've got the runners, A, B, C, D, and E, F, and G. But we have a situation where the number of movable and structural elements do not match up. They may not match up, and they do not match up in this case. We've got 7 runners, but only 5 slots. So in this case, as is the case, or rather potential, as is the case here, is that you can have more movable than structural. In that case, you may need to leave some of the movable elements out. So this is what a potential game might look like, a potential diagram for the game, where you have BCAGF as the runners in slots 1 through 5, in places 1 through 5, and D and E just didn't even get through the first or fifth in anywhere up to the 5th slot. So D and E are out of the diagram. Alternatively, you may need to leave some spaces blank. So let's look at this game. We've changed the game a little bit. It says that runners A, B, and C race once on different days during a 5-day competition, and only one runner races each day. So here we've we've only got 3 movable elements, but we've got 5 structural slots. And so a game might look like this. B races the first day, A races the 3rd day, and C races the 5th day. So this is what I mean by insufficient or excess. Excess basically just means you can think of insufficient as that there are an insufficient number of elements, movable elements, and excess means that there's too many movable elements. And so there's a mismatch between the amount of movable elements you've got and the amount of spots that they have to go into. And you can always, a possibility is that you are leaving some out. The possibility is that you're leaving some spaces blank. Then there's different combinations of that. But these are the basic possibilities. Okay, moving on to balanced imbalance. So what does that mean? So let's look at this game. The game says that runners A, B, C, D, and F are placed in 2 teams. Team 1 with 4 runners and team 2 with 2 runners. So we can have a situation where the different groups can have the same or different amount of movable elements. And this generally occurs with grouping structures, and in sequential structures, it'll sometimes have more than one element in a sequential slot. But going to this, we see that we've got a situation where we've got 4 people over on the left and 2 people over on the right. So that's what imbalance means. They're not in balance. If they were in balance, it would be 3 and 3. You would have the same amount. But if they're imbalanced, you have different amounts. And like I said, this is generally something you'll find in grouping games, more rarely in the sequential games where 2 or 3 elements might double up on a particular slot.